Hello everyone, today we are again solving another Leetcode question, that is Leetcode 22, balanced parentheses. Okay. So what is the problem statement? The problem statement is that we are given an integer n, let's say 4, 5, 3, any number of integers, and we have to generate all the possible balanced parentheses from that integer. Like if we are given an integer n, that means we have one opening bracket and one closing bracket. So how many balanced parentheses we can generate? Only one. This. What is balanced parenthesis? So balanced parenthesis is that every opening bracket should have a closing bracket. This is the basic concept of balanced parenthesis. Let's take another example for n equals to 3. So one balanced, so we have 3 opening brackets and 3 closing bracket. So what we can do? Every opening bracket must have closing bracket, so let's close it. Again open a bracket, close it, again open a bracket and close it. So this is one combination. So open a bracket, open a bracket, open a bracket, and every opening bracket must have the closing bracket. So close this bracket, close outer bracket and close this bracket. This is another combination. So we can form multiple combination. Open a bracket, open a bracket, close it, open a bracket, close it, and finally close this bracket. So this is third combination. So open a bracket, close it, open a bracket, open a bracket, close it, close it. So this is fourth combination. So how many combinations will be formed? How many combination will be formed? There will be 5 combinations. There is not a necessary formula that I tell you to for n equals to 3 this many combinations will be made, but you can solve it by permutation combination, but there's no need. We have to find all these combinations, not the number of combinations. Okay, so we have to generate all these parentheses, and we don't need to tell how many balanced parentheses are there. So let's solve. So whenever I hear the word like generate all combinations, the word which comes to our mind is recursion or backtracking. So yes, this question is again can be solved by recursion or backtracking. So how we'll approach the question? See, you are seeing that for every option we are having a choice. Let's say for n equals to 3, let's try run the code. For n equals to 3, we have 3 opening brackets. Again, we have 3 closing brackets. Now let's open a bracket. Okay, let's not open a bracket. What is our first choice? Should I close a bracket? This is not possible. For the first choice, I have only one choice, that I can open a bracket. Clear? So for the first choice, I can only open a bracket. For second choice, I have 2 options. I can open a bracket or I can close this one. And for again this case, I have 2 choice. I can open a bracket, I can close it. Here also I have 2 choices. I can open a bracket, or no. Here I don't have much. Here you can see I don't have 2 choices. I have only one choices. I cannot form a close bracket because this closing bracket does not has any opening bracket. So I cannot close the bracket. So I have only one option to open a bracket. So how I'll identify that, okay, now I am having only one option, now I am having 2 options? How can we identify? There should be some condition now. So let's check what this condition is. Okay, you're observing that we have we have closing brackets as 3 and opening brackets as 3. Now whenever opening bracket and closing brackets are equal, we have only one choice. See, here opening bracket has become 2, closing bracket is 3. So we have 2 choices. Whenever closing bracket is greater than opening bracket, we are having 2 choices. You can observe here also opening bracket is 1, closing bracket is 3 because we used one opening bracket. Opening bracket is closing bracket is greater than opening bracket, we are having 2 choices. But here opening bracket is 2, closing bracket we are having 2, so only one choices. So whenever opening bracket is less than closing bracket, we are having 2 choices, and whenever opening bracket is equal to closing bracket, we are having only one choice. What about opening bracket greater than closing bracket? This is not possible. This is not possible. If you are doing this, you are going wrong. How? See, why I'm saying this, because let's say you are having opening bracket has 3, closing bracket also has 3. We have to make opening bracket greater than closing bracket, so we'll use closing bracket. But this is not allowed, because every closing bracket should have an opening bracket, so this condition is not allowed. Okay, I hope you got it. I hope you got my point. So what should our code look like? What should our code look like? So first we'll pass two parameters, obviously how many opening brackets we are having and how many closing bracket we are having. Again, we'll pass an string answer to store that, sorry, vector answer to store that generated string. Again, we'll pass a string in which we'll add closing bracket or remove closing bracket for backtracking part. Everything is okay. So okay, now these are the parameters to be passed in the function. What should be the backtracking function should look like? Can you guess what is the base case? Looking at this tree, can you guess what should be the base case of the recursive function? According to me, the base case should be, just see, is this the base case? Is this the base case? Here opening bracket is 1, closing bracket is 3. Is this a base case? No. We have to close now. We have to use all the brackets. So whenever opening bracket is becoming 0 or closing bracket is becoming 0, that's the time we are generating an answer. That's the time we are generating an answer, and we'll store it. So base case will be if opening bracket is equals to 0 and closing bracket also should also be equal to 0, we'll store it. Okay. Now next condition. Next we have shown we have seen that we have two cases. When we are having closing bracket greater than opening bracket, we are having two choices. And when we are having opening bracket equals to closing bracket, we are having only one choices. So we can write it in two functions. But again, when we are having two choices, we have to again write two if else. Like if we'll write if opening equals to closing, just as add opening bracket, and else if opening bracket is less than closing, or opening bracket can't be less than closing bracket. No, opening bracket is greater than closing bracket. Then we are having two choices. And then we can use recursion here. Recursion we'll use here also, backtracking logic we'll use here also, but here we are having two options. So we'll create a string output 1, another string output 2, and then use that, like for output 1 we are using closing bracket, we'll insert closing bracket, and for output 2 we'll insert this bracket, opening bracket. For output 2 we'll insert opening bracket, and again we'll decrease the opening and closing, and we'll pass. This can be the one way, but can I think of a way that both the if, like here else if will work or if will work? We can think of a way that only both the cases should work. Like see, whenever opening bracket is less than closing bracket, or opening bracket is equals to closing bracket, the common choice is that we can use opening bracket. In both the conditions we'll use opening bracket. Constraint is on closing bracket. Constraint, see, if opening bracket is 3 and closing bracket is also 3, so can we use opening bracket? Yes. Why? So this condition holds. When opening bracket is 2 and closing bracket is 3, can we use opening bracket? Yes, we can use opening brackets. So opening brackets can be used in both the cases. So we'll write two ifs. Two ifs, and in each if we'll write the cases when opening bracket should be used and when closing bracket should be used. So when opening bracket should be used, opening bracket can be used whenever opening bracket is available. We can use opening bracket. See, opening bracket less than closing bracket or opening bracket equals to closing bracket. What this shows, that opening bracket is available. When we can't use opening bracket, when opening bracket is 0. If opening bracket is 0, how will you use? So that's why if opening bracket is available, opening bracket is greater than 0, just use it. S dot push back. Just push back, and again solve. This is recursive function. Solve, decrease the opening bracket, closing bracket will remain same, and then for backtracking logic, S dot pop back. So this is a case when we can use opening bracket. This is 0. Okay, this is 0. This is opening bracket, this is 0. So another, if I'll use not else, if why, I'll explain. Whenever closing bracket is greater than opening bracket, only this is the case when we can use closing bracket. So s dot pushback, closing bracket, and same logic by decreasing closing bracket. So why not else if? Because if you write else if, only this block will be executed. Do we want only this block to be executed? No. This is opening bracket. Okay, this is 0 and this is opening bracket. Don't get confused. I'll write it. This is 0 and this is opening bracket. No, I want whenever opening bracket is available, use opening bracket, and whenever closing bracket is available, use that also. So both can be used by this method. I hope you got it. Let's dry run. Okay, let's make a recursive tree. Then you will finally, let's first code it, and then we'll come back and using that code, we'll try to draw the recursive tree. Okay. So again, this is a question. So what we'll need, first we'll need a vector in which we'll store an answer, and vector will be of type string. Let's name it answer, and we'll use a string s, string s, that is empty, and int closing bracket which will be equal to n, and int opening bracket which will again be equal to n. And then we'll use our solve function, which I'll write. Solve function will pass opening bracket, closing bracket, opening bracket, closing bracket, string and answer. And then what we'll do, we'll return that answer. Next, return type of our function is void, because we are doing nothing, just modifying the answer. Solve will get in int opening bracket, comma int closing bracket, comma string s, comma vector string, just a second, vector string will pass by reference, so that the changes should be made in place, not in the copy. Okay, so let's write the base case. If opening is equals to 0 and closing is equals to 0, what should we do? We should store the answer dot pushback, what, string s, store it and just return. Let's write if opening bracket is available. So opening bracket, if it is available, opening bracket is greater than 0, then string dot pushback, string dot pushback, opening bracket, solve with a small s, solve, opening bracket is decreased, then closing bracket, string and answer. And for backtracking, s dot pop back. And if closing bracket, this if is for when closing bracket is available. When is closing bracket available? Whenever is closing bracket is greater than opening bracket. Closing bracket is greater than 0 will not work. Why? Because I have explained you, we cannot put closing bracket anytime. We have to put closing bracket whenever there is opening bracket. And if you're worrying that we have put the condition closing bracket is greater than opening bracket, what if the closing bracket get decreased, will be less than 0? But this will never happen, because whenever opening bracket will get decreased from closing bracket, this if will execute and make it equal to the opening bracket, and again that upper if will execute, and both can get simultaneously get executed whenever opening bracket is greater than 0 and closing bracket is greater than opening bracket. This though both if will get simultaneously executed. Okay, so s dot pushback, what, closing bracket, and solve, opening bracket will remain same, closing bracket, and s answer and again with that backtracking logic, s dot pop back. So this code should work. Let's see if it is working or not. Where is the run button? Let's compile and run. Okay, I am getting wrong answers. Why? For n equals to 4, yes, this is the parenthesis we will get, but why it is only 2? Let me see where I am wrong. For n equals to 4, okay. For n equals to 4, that means you are having 3 opening brackets and 3 closing brackets. Okay. So then n will always be even. Yes, n will always be even. See, so no problem, we'll pass n by 2. Here also n by 2. In Leetcode, the problem was if n is given, so we were having n opening brackets and n closing brackets, so I thought that is the problem, but there is slight change in Geeks for Geeks. There's nothing much. Okay, we let's submit the code. Yes, we solved it. So let's trace this let's trace this function and let's see if how the recursive calls are made. Okay, see, the function is if opening is equals to 0 and closing is equals to 0, what store it. Okay, if opening is greater than 0, s dot pushback, just a second, s dot pushback, and again solve function decreasing. If I'll mark it as 0 to avoid confusion. If closing is greater than opening, use closing bracket. Okay, so let's say n is equal to 3, and n is equal to 3, and that means opening bracket is 3, closing bracket is 3. Okay, opening bracket is 3 and closing bracket is 3. Now which line will executed? Which if will executed? Opening is greater than 0, yes. Closing is greater than 0. Closing is greater than opening, no. So okay, first if will get executed, stack will open string will get opening bracket. Now opening has become 2, closing is 3. So which opening is again greater than 0, opening is again greater than 0, and closing is greater than opening. So both if will get executed. So two options. The s will first contain again an opening bracket, that means this will and this. Now here opening is equals to 2, closing is again equals to 2. यहाँ पे opening is equals to 1, closing is equals to 3. Since this opening is greater than 0 and closing is greater than opening, this will again have two options. This will again have two options like this. Here opening is become 1, closing is 2. Yeah, here opening is 0 and closing is 3. Since opening is not greater than 0 but closing is still greater than 0, for this part I am explaining. So we'll have only one choice of closing. So we'll close will become 2, open is 0. Open is not greater than 0 but close is greater than open, so again only one option, only one if will get executed. And similarly again only if one if will get executed, and we'll get the answer like this. Just a second, 3 opening and 3 closing. Yeah, we'll get answer like this. Similarly here again, since opening is greater than 0 and closing is greater than opening, so we'll get two choices, opening and here opening will 1, closing is 1. Here opening is 0, closing is 2. So here only one option is there. Here closing 1, opening 0. Again one option is there. Since opening is not greater than 0 and closing is greater than 0, closing is greater than opening. So this answer will get. Similarly, if you'll trace, this is your homework, trace this and trace this, and you'll get the final like 5 outputs, 5 results. Okay, I hope you got the code. Thank you.